So, before we start this video, I want to make a quick shout out to my patrons. Thank you so much for the support. You can support me on patreon.com/C#accent, all letters. And if you pledge $5 or more, you will also get an access to a Google Drive where I have all the scripts from the videos, so you can save a little time and help me in the making of these videos. So, last video we see an enemy. We created a basic enemy with some basic enemy AI. We make him follow a waypoint and we make him start shooting at us when he sees us. Now, of course, this is a pretty simple enemy, so let's make him a little more advanced. Now, I don't think I'm going to fit all the stuff I want to make in one video, so we'll probably I'll make a few more for an advanced AI. Now, I have to say that this stuff are kind of an optional, and some games don't even have a need for them. So you can integrate it into your game or not. Of course, there are many other ways to make AI. Okay, we are talking about behavior and what we will present our enemies and our characters with some cases, some events, you can call them, and we will create a logic for what is going to happen when this event happened or another event happens and stuff like that. We're mostly going to work with examples, okay, because in real life there are so many stuff you can do and that can happen, so we can't cover every aspect of what can happen and what can we do, but of course it's going to take much more time, and so that's why you should get this as an example. And you can, with the same logic behind it, you can create enemy AI for other stuff like that. Now, so we have our basic enemy over here. Now, what he will do when he discovers an enemy, it's going to be based upon some variables. Now, in real life, these variables will mostly be if somebody is a trained soldier, will react way different than somebody who is not. As you know, as a police officer, if he sees a thief, he will probably chase him, but some common folk will probably just run away. Okay, this is basically different for every character, but we are mostly going to work with some trained enemies. So, for instance, let me give you an overview of what we're going to do. We will have our enemy over here, and when he sees us, when he spots another enemy, if that is us or another AI enemy, then he will do a quick check. He will look for cover in this room, and he will decide if it's best to start shooting us, attacking us right away, or it's best for him to find cover. Now we will mainly focus on finding the cover and hide, and after that we will see how we can make an enemy to start making decisions of its own. Now, of course, with what we have over here. It's just an empty room, and in everywhere we see inside this room is actually just empty space. Now we have to decide how are we going to say to him that, you know, this place is a good cover. So we're mainly going to work with this door, and I'm going to add a new game object, a cube actually. I'm going to bring it to move it to view, and I'm going to place it into positions that I believe that should make good cover. Now, before we start doing all this, I'm going to change the layer because I want this to ignore the raycast. I don't want any raycast to be interrupted by this, and I'm going to make this a trigger, and I've actually don't even need this to be. I'm only going to add it as a trigger because I want to find it with overlap sphere. So I want to find this with physics, but I don't want to I don't want the cube itself to be affected or affect any other objects with physics, but I have to add it a box collider because I want to find it with physics.overlap sphere. Now, of course, there are other ways to do it, but I'm just doing it this way. Now I'm going to duplicate this, or maybe before I duplicate this, I want to create a new script, and I'm going to call this cover object. Now I'm going to show you a basic cover because we are lacking animations, and with animations we can even set some more stuff. We can do more stuff, but since we don't have them over here, I'm just going to show you a few of the basics, and we will see in the future what can we do. So inside my cover object, this is going to be a pretty simple script for now, and I'm just going to add a new public game object variable, and I'm going to say owner. Now, depending on what we could do, we could add an enum, and we'll say cover type, and you could say if it's full or half and stuff like that. So if it's in games like games like Assassin's Creed, where you can hide under near a corner of a wall or another object, or you can hide under a fence, behind a fence, stuff like that. But since this will require animations which we don't have, I'm just not going to show that. But know that with this cover object, it's basically aura stats for our object. You can even have, if you want to have destroyable cover, you can even add stats over here and lower the health of the cover object and destroy it and stuff like that. So that will be for now for the script, and I'm going to cover it, drop it inside my cube, and I'm actually going to name this cube. Let's call it cover 1. Now the mesh renderer is not actually really needed, but we need the box collider, and I'm going to add a blue over here so that we can take it apart. And let's remove the mesh filter and the mesh render. So I'm going to duplicate it, and I'm going to position it in places where I could say that this is a good cover to have. Now I'm placing it in both ways of the wall over here, and you will see in a minute why. Now of course this will require you to have already predetermined level, so this might not work into a procedural game, but I don't think there are many procedural games that are known for the AI. Now in games like Call of Duty or Battlefield or games like that have a pretty curated experience with a lot of scripted events and stuff like that, you have your level, so it's pretty easy, your level designer, to set this up, and you can have a much more curated experience with all this. So I have all my covers over here, and now let's go open up our NMAI. I already have it opened, and over here I'm going to zoom in. Now I'm going to add a new AI state, and I'm going to say it's cover. Now let's start. We don't want it, so let's close it. The update, we should add a case over here, which is going to be case AI state dot cover, and add the break, and we will see a little later what can we do with this. So I want to close the attack for now, the on animator OK, and the shoot ray, and the patrolling. These are all the stuff we have before. So the first thing we will add will be the cover systems. Now of course, before we even start messing with our, let me just close all this, and I'm going to add our new function, which this will be a function that finds all available covers, and this will be void find cover, or maybe yet find covers. Now we will going to need a few variables before we start writing our logic, and let me quickly see where they are. So let's go up to our variables, and I'm going to add a new public list. Let's make them transform, so we will save some typing, and I will name this list available cover, and we initialize it, which is going to be a new list transfer. So I'm going to add a new game object, and I'm making them public so that we can see from the inspector, although there is not really a need for them to be public. But anyway, I'm just making it public so that we can know and see what we need. So keep in mind, you don't actually need to have them public. So these are the two new variables we're going to need. And now let me just close some of this stuff. So we need to find our cover. Now how we are going to find every available cover? We will actually add a collider array, and we will say hit colliders. Now we're going to use physics dot overlap sphere and the origin of the position we want to start, or the center of our sphere, will be our transform position, and the radius, let's just give it something like 30. Now you can add, instead of 30, you can add the same value as as the site of our enemies. So you have to decide what you're going to do. I'm just doing a 30. Now physics overlap sphere just makes think of it as a sphere collider that takes all colliders it finds inside it and stores them in an array. So first off, we actually need to say if we find any collider. So if hit colliders dot length is higher than 0, that means we have found some colliders. So we can actually start doing we can actually start looking inside our colliders, and we want to say if the colliders, from all of the colliders we found inside our sphere, which ones are cover and which ones are actually cover we can actually use, so that we don't make our enemy go and find cover and his back is actually towards the player. That will not be very useful, and that will make it pretty easy for our player. So we will add a for loop, and we will say for I equals 0, I hit dot colliders dot length I plus plus, and if our hit dot colliders, the I, then game object dot get component cover object. So if the colliders inside our hit colliders inside this array has a cover object component, that means it's the cubes we placed around our level. Now of course we don't want two enemies to go to the same cover, because later we might start lerping from the positions and actually do some other stuff. So you might want to have enemies to go to the same cover, you might not want to have enemies to go to the same cover. This is entirely up to you, but I don't want to have enemies go to the same cover, so I'm going to say if the cover object dot, if there is not an owner, then I want to start saying vector 3. I want to say get the direction, and the direction will be the position of our enemy minus the position of the collider. Okay, we want to have the distance, so we're not doing a raycast indefinitely, and I'm going to say the distance will be from our position to the enemy's position. Oops. Now of course I'm going to check if a cover is eligible as a cover by doing a raycast, and if we first find another collider and that collider is a static collider, that means there is an object there is an object above our player. There is an object between the cover position and the enemy. So that's probably either a wall or a fence that we can go behind and take cover. Now, of course, this is better than being in the straight open area, so the enemy could shoot just straight up to us without having any obstacles in between. So I'm going to do a physics.raycast, hit colliders, I transfer.position. Now I'm going to make it to be a little further up the ground, so that we're not hitting obstacles that are pretty close to the ground. And this will be the distance, and we forgot to add the out hit distance. And something is not right. Let's see what it is. And of course we haven't added the raycast hit. So we do a raycast from our position, from the position of the object, of the cover object. We add the up so that we're not pretty close to the ground. We add and the direction is towards our enemy, the out hit and the distance. So if hit dot collider dot game object dot is static, that means it's probably a wall. So if not available cover dot contains the hit the transform of this collider, then simply dot add hit, add that transfer to the available cover. Now if there is not any hit colliders over here, then there's not much else to do, so we add an else statement and we're probably going to attack. But since we can do even more stuff like retreat or stuff like this, I'm just going to write attack for future references, and we will see on another video, and if we add stats and how do you call it, and morale and stuff like that. So with this we are actually going to find, we will get all our colliders, and it will return and it will store them inside a variable cover.add. So let's see that in action. Now before we do that though, let's bring our enemy somewhere around here, and let's make our character be in front of our enemy so that it will spot him immediately. And enemy, you see our list over here with available covers, and I hit play, and of course nothing is going to happen because we didn't add the find cover somewhere. Let's just go into update and add it over there just for now. Let me put not yeah, come on. I will unmaximize it and hit play, and we're getting some errors because of course we don't have an enemy to attack. And why we don't have an enemy to attack, even though we are pretty much I'm going to drop the third person character to enemy to attack, and it doesn't work. So let me get this over here. Let me see. I will put this beneath the find car, the decide state, or after the decide state. And let's see why. So our enemy over here, hope you can see, let me, yeah, has found us. And if we go to his enemy AI, you will see that nothing happens. Now let me see why, or maybe yet let's just do it together. So we have hit colliders, we have so let's see, let's make a debug log over here, and let's see why, and we will say no colliders. Close it. Let's hit play once again. And for some reason it doesn't actually call the find covers, which is kind of a strange thing. This happens, for this to happen, and since we have hit collider, okay, so let's just write debug.log hit colliders.length. Let's make sure we have all this. So this gets 23 colliders. Now, so we know this is true. Let's see over here. Let's say we know this runs and this is not. So get component a cover object. My guess is probably something over here, font cover object. We take our cover object, and now let's see why this and if it doesn't have owner, we also have it, find an over, so it's probably somewhere with our raycast. So let's add a debug.draw ray, and let's see, we will actually take all this, add it over here, and we will see what happens with arrays. I'm going to pause it, hit play, and you can see that we draw array from every position of from every cover object. We actually draw array towards our enemy. So probably it's over here. And yeah, the reason why this actually didn't work, it's because I have closed the static from all the collision game objects, so I'm going to enable it, but I want to disable the light map static so that I don't actually bake stuff while we're doing the tutorial. Let me go back over here. So that was my bad. So make sure you have your collisions actually static. Now of course you might not be checking if it's static or something like that. You're gonna even add you can even add some components on your walls or something else, or even a tag. I'm just doing the check with is static. So if I go now to my enemy, and you will see here in my available cover I have 4 eligible covers. So the first one is the 7. Now keep in mind these are not in order. Okay, so we're getting up the 7, the 6, the 3rd and the 4th, and all the other covers that will have our enemy to have his back towards our player, we're not even counting those. Okay, so this works exactly how we program it to work. Now of course we might want to make the raycast to start from a lower point, so let's do a subdivision with 2, just so that we know what's happening. So we have all our covers, we know where we can take cover. Now we need to decide which cover. Let me delete that from the update. We don't want this to happen on every frame. So we need to decide, since we know now where we can take cover, we need to decide which from these positions we actually want to take cover. Now the most logical thing to do is actually get the closest cover. Okay, so let's create a new function. I'm going to collapse this so we don't want to, and I'm going to say void take cover, and we will say if closest cover equals null. So if we don't have the closest cover, we know what, let's add the else for now, and if we don't have a closest cover, we want to say if, and we have a variable cover, so the count of our variable cover is higher than 0, we will see. And if we do not have any variable cover, what we want to do is of course find covers. Now if we have a variable cover, and this is where we are right now, then we want to find the closest cover. So I'm going to say CL cover, and I'm going to give it the very first available cover, which is 0, and I want to make a check with the distance, and it's going to be vector3.distance from our position to the available cover dot transform dot position. Now we take the first in our available cover because we want to have something to compare it with. So I'm going to add a new for loop, and I'm going to say available cover dot count I plus plus. You know this stuff, it's pretty much your regular for loop. So I'm going to have a new float which will be our temporal distance, not vector4, vector3 dot distance transfer dot position, and the available cover dot I dot transfer dot position. And we're going to compare the temporary distance with our distance, and we're going to say the CL cover will be the available cover I. So we find for every object inside our available cover dot count, we compare it with our stored distance, with our distance over here, and if it's lower than the temporary distance, then the closed cover will actually be the available cover, our current available cover transfer. So that's all nice, but we also want to add a new check that if we are at the last item inside our list, and that will be if the I is equals the available cover dot count minus 1, because we start from 0. Okay, then our closest cover will be CL cover dot our game object. And what this does is actually finds us which is the closest cover we can use. So this will loop back to this. So in the next frame we'll loop back to take cover over here, and it will actually come over here and say closest cover, it's not null. So let's go to the else. Okay, and over here the else, we can say we have our cover, we know what cover we want to use. So what we have to do now is actually go to that cover. Now before I'm going to do that though, I'm going to add a new function, and I'm going to say move to, and this function over here, let me close a little. So this function over here will actually take a vector3 destination, our bool is SDM, and vector3 the look position. And I'm going to go to our patrolling function, and I'm going to take all this stuff over here, and I'm going to cut them down. So over here I'm going to paste them in my move to function, because we're going to use a lot this function, so we don't want to keep writing this stuff all the time. Okay, so we just simply use it, store them inside the function, and call this function instead of writing everything again and again and again. So the agent.transform will be a transform.position. This stays the same, but the agent.destination, instead of the waypoint dot index dot all this stuff dot position, we actually going to pass this destination, and the velocity is going to remain the same, but the move will stay still the velocity. But since we are accessing the move from here, I'm going to pass, instead of a false, the aim, this boolean, and the lock position to this lock position. So into our patrol function over here, we're going to add, instead of our usual of what we had, I'm going to say move to waypoint index dot position false, since we don't want to aim, he's just patrolling, and I'm going to pass the target position. Okay, so that's the patrolling, that's our move to function, and over here to our take cover function, if on the else statement of our closest cover equals null, so we have a closest cover, and over here we simply do move to, and let me quickly so move to closest cover dot transform dot position. We don't want to aim right now, and then we want him to look towards transform dot position. Now keep in mind, you might not want him to look towards the enemy, so you change this from here if you want. And now we have our take cover function. Now of course we have our take cover function, but we need to decide when will this happen. So let me close this. Let's add on the update over here, let's add the take cover function. So if the AI state is type, then we want to call the take cover function. Now let's go to decide state, and we will actually see over here, if you remember, we checked if we have enemies and if we have an enemy and we can attack. So on the else statement statement over here, instead of turning him into AI.attack, we can actually do AI.cover, AI state.cover. Now I'm going to add regions. This is something we didn't seen before, so I'm going to use hashtag region, and I'm going to say, do we have an enemy? And to the end of our statement over here, I'm going to say hashtag and region. Now keep in mind that in MonoDevelop a lot of the times this won't work, although it's not really something necessary. But if I add a region, you can see that I can collapse this and be more organized over here. So over here I'm going to add a new region, hashtag region, and I'm going to say, are we in cover, and I'm going to add hashtag and region, so that we will be a little more organized, so and we don't have all stuff bothering us, so we can find a way around. So if our AI state equals AI state dot cover. Now, and we know that our closest cover is not null. Let's store the cover object. I'm going to add it C of J and closest cover dot get component cover object, and I'm going to do some checks. So if the cover object has an owner, and if the owner is not this dot game object, so we are not the owners, then we're going to start searching again. So we're clearing every available cover we have. We clear our list and we make null our closest our closest cover. And but if we are the owner of our closest of the current object of this object, then we want to do a check for the distance, so how far we are from the cover, and we will say vector3.distance transfer.position and closest cover.transfer.position. And if the distance is lower than, let's say, 1.3, you can add whatever you want. Then we change our AI state to AI state.attack. Okay, and if, let me see, so if this object does not have an owner, then our cover object owner will be this game object. So the first time it will come over here, it will see it doesn't have an owner, assign it an owner. So the next frame it will come over here, we'll see you have this cover object has an owner. Is the owner, are we the owners? If not, then we clear the available cover, and this is not a legitimate position to cover behind, to use the cover. If it's an eligible cover position, then check the distance, and when we reach that cover, you can actually we change to the attack state. Now you can even you can add even more logic over here. So if you want, if you have animations for cover, this will be the place to make them play. Okay, we don't have animations, so we're just doing it this way. Now let me see, let's hit play and see what will happen right now. I'm hitting play, it doesn't have compiled yet, and as you see, there is a little problem. We have our enemy, we don't have any available cover, and we don't have any closest cover. So let's go back to our script. Okay, so the way we have it over here to find to see if a cover is eligible to be actually a cover by finding if a collider is static or not, it's a little troublesome. So make sure this covers over here, they actually have a collider beneath them, otherwise you're going to have little problems. Make sure navigation is actually, and this is not really a good thing to have, but it gets the job done. But you will see that the agent will actually might get stuck into the corner, so keep that thing, this thing in mind. You can't, if I make the radius a little bigger, it might fix that, it might not, and I probably shouldn't bake the nav mesh while recording the video. So anyway, I'm jumping back to the script. Now I've commented out this inside AI state equals AI state.cover, this because it gives us a little problems over here where it shouldn't. So just comment this out for now. Now, even this is not really something, it's not really ideal. Okay, so the best way, if you want to create a nav mesh agent, is actually the best way is to make actually make a new nav mesh above all this, a new mesh, and bake the nav mesh upon that mesh. So anyway, we have to work with what we have right now. So let me quickly see back. I've changed the distance from to be 1.5. Well, actually, let's just give it 1.3. So when we're reaching that, we reach the cover, we will change the state to actually be an AI state.attack. And I also added check over here, check. I changed the speed of the agent when we are at the cover AI state. We change the speed to 3 so that he's actually running. Now let's go back, let it compile, and when I hit play, we will see what's going to happen. So it finds an enemy and actually runs and takes cover. Now for some reason it's the cover stays at the AI state stays at cover. So let's go back to a script. I'm going to close this debug, and I'm actually going to add the debug. Oh, and also before I forget, in the take cover function, we forgot to add this. So we are taking the temporary distance, we compare it with our distance, but if we don't, we forgot to change the distance to be the temporary distance if it's smaller than if the temporary distance is smaller than the distance, then the next distance we want to do the check is with the smaller temporary distance. So let's go over here, let's add a debug.log, say reached, and I'm going to actually make it 1.5. And let's see, let it compile, and for some reason I can't. Let's hit play, and he will start running, and he reaches, and for some reason he never reaches that position. let's see actually why does this happen. He found our enemy, he finds the position, he turns back, he reaches the cover 4. Now let's add, instead of adding if we reached, let's actually add that backlog and see our distance. Let's close this. Maybe I have the stopping distance is 1.2. Let's hit play. And we actually never get to see, we are never going inside over here, from what I can tell. So we're never doing all these checks. Now why will that be? I don't exactly know. So let's just get rid of all this. Let's take all this, make a cut, and let's just comment all this out the other way, and let's just copy paste it, cut paste over here, and let's see what happens. And of course we need to recompile first. As you see, AI is actually a little difficult to do, and as you see, when we are reaching when he reaches a position of 1.4 under 1.5, he will actually start shooting as he's supposed to do. Now let's see over here what we know. Now this should actually work, but for some reason it doesn't. So let's just delete all that and let's just keep it as it is, and we will see later what we can do about it. So we know we are in cover, and let's duplicate our enemy and see what two different enemies will actually do. And as you see, one goes to the one position and the other goes to the other. And let's duplicate him once more and once more, and let's see what all of them will do. Of course, everybody going behind the cover, and everybody goes to find an eligible cover. Now this actually have there is a collider over here, that's why they are shooting and the bullets are not going through the glass. But anyway, we don't it's not really a problem right now, and that's how we make our enemies, instead of just sitting around and shooting us. That's how we make them find cover first and then shoot at us. Now of course we might not want to add we might not want for them to hit to find cover. He might have a better weapon than us, and so it's more logical that he will start shooting if he has a rifle and we have a pistol, for example. It's more logical to start shooting at us, since, you know, he's got a rifle. So let's close this and this and this. Now inside our shoot array, let's just add also over here weapon manager dot active weapon dot current ammo minus minus, so we lower our ammo, the ammo of our enemies. Now close all this, and now let's go back to our decide state. So over here, if we have an enemy, okay, instead of immediately telling him to find cover, we can actually add some more checks. Now I'm going to add a boolean which I'm going to call decision. Now it's more wise to do it a little different way, but I'm just adding the boolean of the decision just so that it happens only once, because we don't want him to decide every frame. Okay, and decision will be true. We will see later how this can be done. So we need actually a function that it's going to tell us what are we going to do. Now instead of adding it over here, I'm just going to go into our shared functions script. If you remember it, we created a few videos back, and I'm going to add a new public static bool, and I'm going to say compare weapon, and we're going to pass weapon control. For short will be weapon 1, and we're going to pass a weapon control. It's going to be weapon 2. Now of course we need, since this expects for us to return a value, so we will add a bool return value, and we will actually return this value also. Hit enter so that it goes down, and next we will say if weapon 1, so if our weapon type equals the weapon type of, it's the same as the weapon type of our enemy, decide. Now before we write a decide from there, we will see if we don't have the same weapon. So if our weapon 1 weapon type equals weapon manager dot weapon type rifle, so if we have a rifle, then we will return true. So that means we will attack our enemy since we have a rifle, even if the other guy has a rifle. If we have the same weapons, we will see how we decide. But if right now we only have two types of weapons, we have a rifle and a pistol. So if we have a rifle, then probably the enemy will have a pistol, so we attack. If our weapon type is a pistol, though, then we could add a check for the weapon type of our enemy, and if he has a pistol, now actually this might not even be too much necessary, since if I have a pistol and he has a pistol, then it's actually going to be it's going to call this stuff, but let's just add it since you might want to add a shotgun and other weapons like that. So I'm just adding some so that you can know, so that you will know what how you can write it and check, do all these checks. Okay, so basically if we have a rifle, we attack immediately. If we don't have a rifle but we have a pistol, then we check if the other guy has a pistol, then we also attack. But if he has a rifle, then we will return false, so that means we will actually look for cover first. So if we have the same weapons, it will actually be we will actually have to decide. It will be 50-50 if we're going to attack or find cover, and that will actually be decided by Unity. And the way we'll do that, we want to take a random range between 0 and 11, so we have 10 values, and we will say if the random minus is equal or lower than 5, then we will attack. Now if we have classes, or maybe let's just say if we have enemy classes like support, assault, or whatever else, we can manipulate the outcome by adding to the random value we get. And actually, let's just make this a little more clever. Okay, let me, just so that I don't have to comment every line. So for example, an attack and the assault class will get a +2 on the random number. So instead of 50% chances of him attacking, he will have 70% chance of attacking. Now we can actually do the exact opposite. Another example, a support class will get -2, so it will have 30% chances of attacking. Okay, now this is the basic way you can do stuff like skills, decisions, what you know. It gives a random factor, but it's not really that random. There is a chance, just like in real life. You know, if you want to decide, let's say you are hungry, and you have to decide if you want to eat pasta or, I don't know, burgers. You have your variables. Now, what variables you have if you have eaten? Now, one variable you can use is what did we eat yesterday. So you have your burgers, and let's say you have a burgers and a pizza. Okay, are some pretty popular foods. So if we ate yesterday pizza, then there is a slight chance we might not want the same food as we ate yesterday, so we will choose burgers. Now, if we ate burgers yesterday, there's actually and even more there is the possibility that we do not want to eat burgers today, so we will choose pizza. Although probably in this argument, probably pizza will always win. So anyway, you get my point and the thought behind it. Now, there are many ways to actually calculating random values. We're just going to the easiest way. This way, it's more of an RPG approach to all this stuff and how you can do AI and stuff like this. If you ever play pen and paper RPGs, okay, you have a game master or dungeon master, depending on what game you're playing, and on an encounter with an enemy, he will actually throw a dice, and based on some variables and some statistics, then he will decide the outcome towards what the dice fall. And we're actually doing the same, but instead of having a game master or a dungeon master, we just simply compute all this, and we're doing it by scripting. Now this gives a little more character into our own character, so that every decision is not actually the same every time. So let's go back to our enemy I, and on our decision we will say, if we haven't made the decision, then we will say if shared functions dot compare weapon, the weapon we want to pass first is our own weapon, active weapon, enemy, and the next one will be enemy to attack, get component, weapon manager, active weapon. So we pass our weapon and the weapon of our enemy, and this will be active weapon with a capital A. Else, so if this returns true, then we have a superior weapon. Else, we don't have a superior weapon, so AI state will be covered. Now, let's add some comments over here so that we know what's happening. So we say we have an enemy, so we haven't added a decision, we haven't made a decision yet. Compare our weapons. Our weapon is superior, so attack. Else, our weapon is inferior, so take cover. And this, we don't want this. And in the end we make a decision so that this happens. We want this to happen only once. We do this because if we have random decisions, so if we have the same weapon, if we have exactly the same weapon, then the random numbers will go every frame, so every frame our enemy will make another decision and another decision, so it will never be that good. It will never actually make a decision in the end. So let me close the new enemies we make. I'm going to leave only our first one. Now, as we know, of course, we have the exact same weapons. I have a pistol, he has a pistol. Let's hit play and let's see what he will decide to do. He decides to fall back and find cover. Now, let's see what next. The next thing he will do. He decides the same. Let's see once again. And once again. He's probably a coward. Now, let's see where this all cowardice comes from. So I'm going to add the debug log. And I'm going to check what exactly is the random integer he returns. And I'm going to note this, that's wrong. I want this. I'm going to delete the distances. We are adding all the distance. Let's hit play. And he decides 8. Of course 8 is higher than 5. You can see it in the console. He decides 3, so he stays right there and he starts shooting immediately. Let's hit play once again and it's the same. Now let's open up all our enemies and let's see what will happen. As you see, 3 of them decide to shoot right now, and the other one is a chicken and he starts running to find cover. Let's see what will happen once more. See, 2 of them decide to fall back, so they stayed for support. Let's see it once more. And all of them now decided to shoot at me. Now let's change our weapon. I'm going to take my rifle over here. I'm going to parent it under my character and I'm going to add it into my weapon list. And I will start with a rifle. Okay, now even though they are 4, they actually, and he decided to move because I need to have this on his trigger. We are missing a few checks. So even though they are 4, they actually, every time I hit play, they will actually always fall back and retreat. Okay, but let's duplicate that. Let's drop it under one enemy. Let's use the weapon list. Let's drop it into our enemy's weapon list. And we actually have to change his weapon. Let's make it into a rifle. For some reason it doesn't change. Maybe we haven't added the functionality for him to change it. Oh yeah, he actually, yes, we had the same weapon, so even though he has a rifle, he starts shooting at me. Okay, that's one basic way to make AI. Now let's see one more example. Now I'm going to this enemy over here. I'm going to go to his weapon, and we are near 1 hour and a half, so I'll try to make this quick. I'm going to add 2 weapons. Okay, but I want the revolver to be first, and his rifle. Where is the rifle? Where is it? Oh, yes, here it is. I want the rifle to be second. Now, before he starts shooting, now let's go to attack. On the attack, so on his attack rate, when it's time to attack, I want to say, let's call our shared function, and I'm going to say check his ammo. I'm going to pass our active weapon, and if it's true, which means we have ammo, check to see if we have enough bullets, and shoot. But if we do not have bullets, then what should we do? Should we reload? And I'm pretty sure you've heard the quote, switch to your secondary weapon, it's faster than reloading. So let's do that. We're going to shared functions, and I'm going to just say a public static integer, and we will say return random int. Okay, because I'm going to be using this a lot, so let's just make it a static function, a static integer, and be done with it. And what should we make it? Let's say int return value, and this will be random range. Was that correct? Did I forgot how to write it? I've actually forgot how to write it. Anyway, so we'll return a random integer between 1 and 10, and we want it to return the return value. And over here, not over here, into our enemy AI, we will say if shared functions dot return random integer is lower than, let's make, do we want to make it 50-50? Let's make it 50-50. Then how did we call it? Then let's say, do we have weapon control dot, no, I want to say reload active weapon, else, and this is actually a function, so let's call this weapon manager dot active weapon equals, is it weapon manager dot weapon list, okay, no, weapon, let me I forgot how to do it. How did we change it? I think we have an indexed somewhere. Did we? Did we not? Let me wait. Let me see into our user input script, and it was somewhere around change weapon. Yes. So where is it? Enemy I, active weapon, and weapon manager dot active change weapon. Let's say true. And let's see what this will actually do. Now, before we do that, of course, let's see if we don't have any errors. Now, of course, this he will shoot 5 times right now. So I'm going to change his maximum ammo and maximum clip ammo. Let's make it 3. Okay, 3. Now I want to change to make the pistol over here. On my character to have a pistol, so that we're not so that we know what will be the outcome, so that he shoots at us. And where was it? So if I hit play, let's hope he will decide to shoot directly without taking cover. Now he will shoot after 10 seconds, as you remember. Now all of them, of course, decide to attack. After 3, the 4th time he will try to shoot. You see, instead of reloading, he decided to change his weapon. Let's see that once more. And I'm going to make him to do it the 2nd time he will shoot. So I'm giving him the current ammo value of the current ammo to have 2 bullets. And let's add the debug log over here. Debug.log. Let's say I decided to reload. This needs semicolon over here. And I decided to, let's just say, switch to the sidearm. It's, let's just simply say it's faster than reloading, and I'm pretty sure you understand where this is from and which game it's from. It's pretty known game. And let's hit play. He shoots 2 times, and the 3rd time he decided to reload. So the 3rd time he will actually start shooting. Of course, we don't have the animation play, but I think we have an animation for reloading. Let's see. Do we? No. This is the weapon. Yeah, we have an animation to reload, so let's make him reload actually, instead of just writing this. So let's say anim dot set trigger reload. I hope I named it reload, and this is the hope it's the correct. Yes, correct. Let's hit play. Let's see once again. Now AI is pretty Now he decided to run away. I like when working with AI, it's nice, so when we get so random, we don't exactly need how do you call it? Anyway, do you get my meaning? It's really nice when playing with AI. Now as you see, he decided to reload. He will shoot 2 more times, and let's see what he will decide to do next. He decides once again to reload. Now of course, the same way as the other one, you can add more traits, so you can take the random number and affect how he behaves. Okay. And so for instance, if you have a trait, let's say, I don't know, anyway, just like the traits you have in Fallout, for example. So he will actually, as you see, he decided that it's faster than reloading, so he starts shooting. Now of course the rifle has a lot of bullets, so this will take will take him 3 or 4 times around 30 bullets. So let's just sit here until he stops shooting, and let's talk about our stuff. So what we do today, we make our enemies before attacking us. We make them find cover first and then attack us, but we have all positions in our level that are eligible positions for us to cover behind. Okay, so we don't hide, and it's not a good spot for us, for the enemy to hide. And we check every position if it's, as I said, if it's a good position to hide, and if it was, we found the closest one, and we keep, and we make our character go over there and start shooting. Next, if we add it, we actually make him decide if it's okay, if it's more productive to start shooting us right away, or if it's more productive to actually, instead of shooting us right away, find cover. And the way we do that is by comparing what weapon we are carrying and what weapon the enemy is carrying. Now you could add an even more into the random values and the random numbers we use to decide. You could add something like a reflex value, so how fast an enemy will actually react into our own actions. So for instance, a high reflex value will make him actually decide faster and, you know, be more effective in battle. If an enemy has low reflex value, it will take him more time to decide and to choose what weapon, and to understand maybe what weapon we are holding. Okay, so that will probably make him fall back and find cover until he's aware of what is the current situation. And as you see, he decided now to take cover, and we start shooting at him. Let's see that once again. Now there are a lot of things you can do with this system, and there are a lot of other approaches for systems like this. Okay, this is just simply one way to do it. Of course, this needs a lot of policing before you do, or you can do a lot of stuff actually. Okay, that's a lot depends on what you're going to do, and if you want stuff like this inside your game. You usually see it in other games at some extent, but as far as I'm concerned, a lot of these now you see he's actually aiming at the wrong position for some reason. It's okay, we are not judging. And that he's aiming like that because the animations are not the same as the ones when we aim with a pistol. So you need to add a little offset to the IK when you are aiming with the rifle. We made something similar like this. So anyway, as I was saying, let's close this up. We did a pretty good stuff over here. Of course, this is pretty much an unpolished state, so it will require a little polishing. Now, AI is a pretty big section in games, but having something that is not too much, you know, when the player doesn't know what will happen next, will actually make him play and replay the game again and again and again, because you know it's funnier that way. If you play games like are a single corridor with just shooting stuff and you know exactly what everything is going to happen, then it's a little boring. Even though some games that do a curated experience, like the single player in, you know, Call of Duty and other FPS, even though they are a different way of the game we're trying to make over here. Now, to each his own. Okay, every game is a good game if you're having fun with it. So this was one example of an advanced AI. Now, as far as I am concerned, the third-person shooter series pretty much to its end. Okay, even though there are a lot of stuff we can do, they are not really necessary just for the third-person shooter series. But I might do another episode. I might do an advanced AI 2, which I'm currently thinking I will do, because even though I wanted to do even more stuff. So let's say yes, let's say I will make another one of these, because yeah, I want to do some more stuff, and I want to let's make our enemies to be even more funnier, even more you know, experienced soldiers, so that we have even better and funnier game, and it will be more enjoyable. So in the next part you will see even more examples for advanced AI. Okay, and we will see what we will do about them. And right now that I'm thinking it, we actually can do a lot of more stuff like this. So I hope I wasn't too confusing in this part. Okay, even though we are running in near 2 hours, we did a lot of cool stuff and a lot of nice stuff, and we added enemies that actually worth being enemies. Now, before we close this, let's just take the duplicated enemy. Let's make him also an enemy of this enemy. So these are two enemies, and if you remember, we say if we change the ID to whatever else, they will actually start shooting one and the other. So one will take cover here, and the other will take cover to one of these places. Now, of course, one will decide what will happen next. One might decide that it doesn't worth he doesn't want to attack, and the other might decide that he wants to take cover first before attacking. So I don't know the AI we made over here. I don't know what is going to happen. Let's hit play, place your bets, and that was a little stupid. Anyway, place your bets, and he decided to moonwalk, and the other one decided to start shooting. Let's do that again. And the same happens here. Now, as I'm thinking it, now forget that, because right now I'm thinking that these objects might get the cover objects might get an owner, but the owner might be an enemy. So that's why probably they don't want to do. They might not want to go there. So anyway, I don't even know why he does that. But yeah, I think I know. Anyway, that was it for the day. Okay, you have a lot of polishing to do with this. I will make in the next video. We will see some more examples. So that was it. Lots of cool stuff today. Don't forget to like, subscribe and share it. Please support me on Patreon if you can. It helps us a lot, and in return you get all the scripts I make in the videos, so you save some time writing the scripts, and you also help our community to make more videos like this. So thanks for watching, and I'll see you next time.